Lesson 24C, day 4 of exponents. We're going to continue with simplifying expressions, but this time we're going to include exponents that are negative and 0. So we've been working so far with only positive exponents. And you're going to talk about the pattern there to figure out the rule of how to evaluate negative exponents. So let's just review all the things we've learned so far first. This is exponential form. You read it as 3 to the 4th power. What is the big number called? The base. And the small number? Exponent. And then if I asked you to write it all out, what would that be called? Expanded product. And when you solve it by multiplying? Evaluate. Then we talked about the difference between negative problems that have parentheses and doesn't have parentheses. So if it doesn't have parentheses, you're not repeating the negative. If it does have parentheses, you are repeating the negative. Everyone understand the difference here, right? So this one would have what answer when you evaluate it? Positive or negative?
Negative.
Ooh, I heard mixed answers. This negative is not in parentheses, so it doesn't repeat. So it looks like this. Should be negative. Negative 25. How about this answer? This one is positive because it is in parentheses, so it does repeat. Okay? See the difference? Everyone okay? All right. This one has parentheses, bunch of negatives. So is that negative repeating?
Yes.
So when you write your exponential form, should it be in parentheses? Yes, that whole thing is repeating 4 times. So negative 2 in parentheses to the 4th power. Then yesterday we learned division. This is 5 repeating 6 times divided by 5 repeating 4 times by multiplication. So we can cross cancel. When you cross cancel, it doesn't become 0. It's 5 divided by 5 is 1. 5 divided by 5 is 1. 5 divided by 5 is 1. So this is 5 squared over 1. We don't need to write the over 1. Just 5 squared. But if the leftover is on the bottom, you do have to write the 1 on top. Okay, remember that? So here's our new stuff. Let's start with the positive ones because we know that, and we're going to figure out this pattern here. From 2 to the 4th power, let's write that as extended product. That's 2 times 2 times 2 times 2. But I want you to write a times 1 at the beginning, and you're going to see why. And it's okay to write times 1, right? It doesn't change anything. Still the same answer. Multiply anything times 1, it's still the same answer. So 1 times your extended product. What would the answer be? 16. Do the same thing all the way down to 2 to the 1st. So this would be 1 times 2 times 2 times 2, which is 8. 1 times 2 times 2, which is 4. And 1 times 2, which is just 2. I'll let you catch up. Okay, so far we've looked at the exponent, and that basically tells us how many times to write that repeating number when we multiply, right? So the 4th power, that means we wrote the number 2 4 times. The 3rd power, we wrote number 2 3 times, then 2 times, then 1 time. So what do you think I'm going to write? How many times am I going to write the number 2 for 2 to the 0 power?
0.
0 times. But I'm not going to write the number 0. That's how many times I'm writing the number 2. So I'm just not going to write the number 2. I'm still going to write 1 times, I'm not going to write the number 2 because it says don't write any. You see that? That's the number of times I'm writing it. So it's not times 0. That just means I'm not writing that number. So 2 to the 0 power equals 1. In fact, anything to the 0 power will equal 1 because that means you're not going to write that base number at all. But you do still have times 1 because everything was times 1. So the answer to anything to the 0 power is 1. So now I want you to draw an arrow from 16 to 8. And that is, how do I get from 16 to 8? Divide by 2. Go ahead and note that in your notes. We divided by 2. Then 8 to 4, we also divide by 2. Then from 4 to 2, we divide by 2. 2 to 1, we divide by 2. And then fill in the blanks here. Positive exponents mean that we're repeatedly multiplying. 1 times whatever, 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 whatever. Base times base times base times base number. And any number to the 0 power equals 1. Because again, that just means I'm not going to write the base number at all. It's just times 1, which is just by itself 1. So even if I have like 100 million to the 0 power, the answer is still 1. Because I'm just not writing that base. Okay? Now let's continue that pattern of divide by 2 and continue going down our list. So we have 4, 3, 2, 1, 0. What comes after 0? -1. So now I'm going to finish my list, which is on the bottom half of your notes there. Now we have 0 and then -1. So I just rewrote what I have here. 2 to the -1. So far my answer is 2 divided by 1. 2 divided by 2 is 1. Now I'm going to do this again. Divide by 2. What's 1 divided by 2? As a fraction. 1/2. So the answer to this will be 1/2. And the way you write this is 1 over the base number. I'm going to divide by 2 again. This answer, 1/2 divided by 2, is going to be 1/4. And an expanded product, it looks like this. 1 over, this space is repeating twice. The exponent does say repeat twice. So 2 times 2, which is 1/4. This one says repeat 3 times. So 2 times 2 times 2, but I'm dividing by 2. So it's going to be 1/8. And then this will be 1 over 2 times 2 times 2 times 2, because it says the exponent is 4. So 1/8 divided by 2 would be 1/16. So negative exponents, notice how none of these evaluated answers is negative, right? It's just a smaller and smaller and smaller fraction, because if we continue the pattern, we're just cutting it in half again and again and again and again. Like if you take a slice of cake, cut it in half, cut it in half, cut it in half, cut it in half, cut it in half. It just gets skinnier and skinnier and skinnier and skinnier. It never becomes negative into like a negative cake, right? You just keep cutting it until it's so skinny it's like paper. Same thing here. We're just dividing it by 2. It's going to become smaller and smaller fractions. It never becomes negative because of the exponent. Make sense? So now fill in the blank on your notes. Negative exponents just mean that you're repeatedly dividing. It's getting smaller and smaller and smaller. Whereas positive exponents means it's getting bigger and bigger and bigger because you're multiplying by more and more bases. This next part is not on your notes so that you can see the pattern. 5 squared. This would be 5 times 5, which is 25. If I have 5 to the negative squared, this will be 1 over 5 times 5, which is 1. If this answer is 25, what do you think that answer is going to be? 1 over 25. If I have negative 3 in parentheses squared, that would be negative 3 times negative 3, which we all know. But if I have negative 3 to the negative second power, that would be 1 over negative 3 times negative 3. So if this answer is 9, what do you think that answer is going to be? 1 over 9. If I have negative 2 cubed without parentheses, meaning that negative does not repeat, this will be negative 2 times 2 times 2, which means this one will be 1 over negative 2 times 2 times 2. So if this answer is negative 8, what do you think this answer is going to be? Negative 1 over 8. See the pattern? Now for the fraction. If I have 3 over 2 cubed, we know that that's going to be 3 over 2 times 3 over 2 times 3 over 2, right? How do you think I'm going to write the negative exponent side? You're right. This would be 1 over 3 over 2 times 3 over 2 times 3 over 2. But that's a crazy fraction, right? But it's just a complex fraction which we all know how to deal with. This is actually 1 divided by 3 over 2, right? We know how to multiply by the reciprocal. 1 times 2 over 3, which is just what? 2 over 3. So instead of writing 1 over 3 over 2 over 3 over 2 over 3 over 2, I can just write 2/3, 2/3, 2/3. So this is 2/3, 2/3, 2/3. You could still do the 1 over thing, but then you have to simplify it with keep, change, flip. And you'll see that it's just a reciprocal. So if this answer is 27 over 8, what do you think this answer is going to be? 8 over 27, right. So let's do some practice on your paper. I'll do the first few with you. Number 1, 2 to the third power would be 2 times 2 times 2. Go ahead and write it in expanded product as practice for today and on your homework. Because now that we have everything, all the different types mixed together, it's going to be easier for you to make careless mistakes. But if you write it in expanded form, it'll be very obvious to you what the answer is. So 2 times 2 times 2 would be 8, which means that this one would be 1 over 8. If this one is 6 times 6, what do you think this one's going to be? 1 over 6 times 6. Very good. 3 to the fourth power would be 3 times 3 times 3 times 3. So number 6's answer would be 1 over 3 times 3 times 3 times 3. Go ahead and finish those. 9 times 9 times 9 would be 9 cubed. So 9 to the negative third power would be 1 over 9 times 9 times 9. So 1 over 729. Any questions on 1 through 8? Great. So now let's look at some fraction ones. So the first one we all know is just repeating half. So half times half times half. Now number 10 says half to the negative third power. So you can either do it the long way and have 1 over half times half times half, which is a complex fraction, which you have to then invert and make it 2 over 1 times 2 over 1 times 2 over 1. So that you see that it's just 2 times 2 times 2. Or you can just realize that this is the reciprocal. So that would be 2 times 2 times 2. So if this one's 1/8, this will be 8. 2 times 2 times 2. 2/5 times 2/5 means that this one would be 5 over 2 times 5 over 2. So if this one is 4/25, what would this one be? 25 over 4. So it should be clear now, hopefully, that if you see negative exponents, the answer is going to represent the reciprocal of if it was a positive exponent. Right? So 13 through 22, I mixed everything together. Go ahead and do all of them, and then we'll go over them together. Number 13's answer is 1 because that says write this base 0 times. So we just have a 1 because we always have a 1 there. Number 14, Noah. Very good. 16. 4 times 4 will be 16. Number 15. Somebody else? Ethan? Good. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2 would be still negative 32 because negative times negative is positive. So these pair up, and then we have one more negative left over, which makes our final answer negative. Number 16. How about Sophia? Sophia T. This negative does not repeat. It's not in parentheses, so leave it out. And then repeat the 5. So this will be negative 125. 17. Scott. Very good, negative 9. So we have a negative on the outside, and then another negative that repeats. So the repeating one becomes positive, but we still have the outside one to make the whole answer negative 9. Who got those first 5 right? Looking good, guys. Moving on, number 18. Go ahead. Good. This is 1 over 3 times 3, which is 1 over 9. 19? Sean? 1. Good. Just because this is negative doesn't mean the answer is negative. It's any base to the 0 power. So this base doesn't even matter what it is. The answer is going to be 1. Number 20. Go ahead.
Negative
1/8. Yep. This is 1 over negative 2, negative 2, negative 2, so that's negative 1/8. And I did write it 3 times here to show you it does not matter where you put the negative, whether it's with the bottom number, top number, or in front of the whole fraction. It still just means negative that fraction. Okay?
I got 1 over negative 125.
So negative stays on the outside. The 5 repeats 3 times on the bottom. So negative 1 over 125. And again, the negative could be front, top, or bottom. Negative on the outside. And then this negative 4 repeats twice on the bottom. So negative 1/16. Alrighty, that's it. Number 1s, what'd you learn today? Ready? Share.